Guys, today we're going to take this beast and make the world's first true hybrid nitro electric basher. That means we're going to attempt to install this nitro engine while keeping the electric motor and ESC. Is this going to be awesome? Is it even possible? Let's find out together. But before we rip this thing apart, let's get one more run in pure electric form.
All right, first off, let's get a baseline top speed on this thing. With the Max 6 ESC, it's going to be a little bit faster than the stock ESC, but not a lot faster. And this thing is so much fun to drive. I cannot wait to see how it runs with both an electric motor and a nitro engine in it. Hopefully we can make this happen. Let's get one more quick pass on it. Full throttle. All right, let's see what we got. Bring her on in. This thing is so much fun. 47 miles an hour, that's pretty much what I expected. That's what we were getting before. And of course, being two-wheel drive with that TSM and the stability of this thing, it is an absolute blast. Those paddle tires really kick up the grass, and this thing is a ton of fun. I can't wait to see what it's like with a screaming nitro engine and the electric motor going at the same time. It is definitely going to be an interesting project. Of course, since it has paddle tires, we need to do a couple of sand pulls. Woohoo! Gonna have to be a little more careful on the throttle. I forgot how much jam that Max 6 has. But yeah, this thing feels really, really awesome. If you haven't tried one of these Traxxas Funcos, you really should at least try to drive one, because it's a completely different driving experience from anything else I've ever had. And it really is the most fun two-wheel drive car I've ever driven. It's a lot of fun, but now let's get to modding.
The first thing we're going to need to do is figure out exactly where this LRP ZR32 is going to go. This is about the most powerful basher style engine I could find, and it is an absolute unit. I want to thank A-Main for sending this and all the other nitro related stuff along to help with this project. But as far as mounting it, we're going to have a challenge no matter where we put it. I'm thinking we might be able to put it beside the electric motor here, maybe flip it around and mount it back here. That'd be kind of cool since the plastic fake engine's already back here, or maybe on top of the electric motor, possibly on its side. No matter what we do though, the first step's going to be disassembly of what's already here. I genuinely have no idea how this is going to work out. I know it's going to take every bit of skill I have and most of my tools. This is going to be the most complicated modification I've ever done on one of these cars. No matter where we mount it, we're going to have access to this spur gear, and that's going to be our first problem. Neither the X-Maxx nor the XRT rely on this cover to hold anything in place, but that's different on the Funco. As you can see, the spur gear is now loose, which means in order to get access to this spur gear and still hold it in place, this is going to have to be modified pretty significantly. In anticipation of that, not wanting to have to deal with this disgusting greasy thing, I went ahead and bought a spare. Let's get to chopping. Essentially, our goal is to gain access to this area in here from the top without disturbing this bearing mount and this bearing mount, and while keeping as many screw hole locations as possible. I think we can do that by just taking this whole top area and cutting it off right here. I could do this with a Dremel or a hacksaw, but we've got a CNC machine, so let's use that instead. This is the Carvera. It's the most advanced desktop CNC machine you can get, and we're going to be leaning on it really heavily during this project. Before we start cutting though, we really need to figure out where we're going to try to put that nitro engine. The engine can only spin one way, and that's counterclockwise from the front, and I'm not sure if we can reverse the drive direction in here. I know on the XRT and X-Maxx you can, because the differential can just be flipped around. However, on the Funco, this is where the actual direction is determined, and because of the way this is designed, it can't be reversed. And that means if we mounted the motor this way, it would actually be driving the car backwards, so we're gonna have to mount it this way, and I think this spot is the best area for it, so that means we need to trim this part of the cover. We're gonna have to be pretty precise with our trimming, because one of the bearing supports is right under where we're gonna need the hole. I think we can get away with just making a window right here, and we're gonna try and keep it as high as possible so this bearing's still supported, though it still might be a problem because it's not gonna be supported from above, so we're just gonna have to see how it works out. This thing's a pretty odd shape, and in order to position it accurately in the Carvera so we can cut it, I've got a pretty cool trick. As you can see here, I've taken a picture of the underside of it. We're going to import that picture into Fusion 360. Then we're going to measure the distance between a couple of these holes, use that measurement to calibrate the size of it. Then we can add our holes based on the picture, replicate the top of the cover. This doesn't have to be perfect. It just needs to be the same basic shape as the cover. Then we can go in and create a cutting strategy in CAM. This will allow us to drill holes in the spoil board, which we can then attach the the cover to. Being precisely located, we can now cut our hole in the top. I'm just going to be using a standard 1/8 millimeter end mill for this. The Carvera does have built-in chip evacuation, so it'll vacuum everything into this little container right here. And there we go. As you can see, that makes a much nicer, more precise cut than we ever could do with a Dremel. Let's see if it fits. All right, popping that on there, we can now see the spur gear, which is nice. Unfortunately, to check the fit of the Nitro engine, we're going to have to remove these fans from the electric motor. And I'm pretty sure for this part of the experiment, these are just going to have to stay off. That's not a big deal, though. Looks like the Nitro engine will have decent access to the spur gear, but we need to put the clutch bell on to be sure. Because this Nitro engine is going to be under a pretty heavy load, A-Main also sent us a really heavy-duty clutch system. Basically, these clutch shoes ride on these little pins and they're held in by springs. As this spins, the clutch shoes get slung out by centrifugal force. They press against this clutch bell, which is what couples the engine and the gear together when you hit the throttle. The nice thing about this is that they're going to be decoupled at idle, so we will be able to run the electric motor independently, though unfortunately we probably won't be able to run the Nitro engine independently of the electric motor without taking the gear off the motor. This kit comes with 3 sets of clutch springs. I have no idea which one's going to be the right one, so we'll just try the medium strength ones and see how they work. The clutch install is pretty straightforward. We just slide on this tapered collar, put the clutch in on top of that, make sure nothing's touching, feels pretty free to me, and then install the nut. I'm not going to install the clutch shoes now because it's pretty fiddly and I suspect this is going to have to come off again. But on top of that, we just install the clutch bell and then we just pop the screw in the end. Again, I'm going to be doing this temporarily, so we won't tighten it up. And now bringing this in, we can see we've got plenty of room for the gear, but not enough room for the clutch bell. That means we're going to have to clearance this area quite a bit more. I'm definitely concerned we're not going to have enough support for this front bearing, but we don't really have any choice, so let's get to cutting. All right, took a few tries, but I think we finally got it. Let's see if we've got clearance for the clutch bell now. And yeah, guys, I think that's gonna work. The next thing we need to work on is actually mounting the engine, and I've got a couple of cool ideas for that as well. What I wanna do is take this piece of 3mm carbon fiber. This is super strong. And then we're gonna cut a pocket here and here, have that piece extend out this way, and actually be mounted in with the electric motor. That should give us a platform to mount the Nitro engine on. And by putting similar slots in it to the motor mounts, we should be able to adjust it as well. As I've been setting this up, I've realized we're going to be using this entire side of the car for the Nitro engine, and we're not going to be able to put a battery over here. That means we're only going to be able to have one battery in this truck, and I definitely want to keep it 8S. So I picked up this single giant 8S battery. This thing's only 3,500 milliamp hour, but it's claimed to be 150C, and Ovonic makes decent batteries, so I think it's going to work, but we really need to test this out, because if this isn't powerful enough, we're going to have to figure out something else. In order to go with that, I went ahead and picked up this ISDT Air 8. This is a little 8S DC powered charger. I had to buy this thing because even my most powerful charger only goes up to 7S. Let's see if this is going to work. Because this charger is DC input only, I have to have an external power supply. I just modified this 750 watt Hewlett-Packard server power supply. I'm not really going to get into how I did that because you're not really supposed to do this, but there are plenty of tutorials online that show you exactly how to do what I did. As you can see, she fired right up. Let's plug in the battery and see if it'll charge. Yep, everything's working great. Let me get this battery charged up. Let's throw it in the XRT and see if it's actually going to work. Because we're only going to be using one battery and these cars are set up for 2, we're going to need a jumper for the empty position. I don't have one for a QS8, but they're really easy to make. All you need is the appropriate female connector and an appropriate piece of wire. This is 10 AWG. It should be plenty thick enough to handle the current and is thicker than the wires on the battery, so it should be fine. So first, we're just going to tin up our wire. I'm using a little holder I got on Amazon. These are specifically designed for this kind of job. These things are super helpful. I previously gave one of them away. Why don't we go ahead and give another one away? Stay tuned. Later in the video, I'll tell you exactly how you can win one of these. And now we just need to tin up the connector as well. Solder up one side. Don't forget your cap. And then solder the other side. And now we're all set. Let's go see if this battery's got enough jam. All right, the goal here is just to make sure this battery can actually handle the stress of being in one of these big cars. If it can take this XRT, then it shouldn't have any problem in the Funco. Looks like we can do good wheelies on here. The other thing I want to make sure of is that it's not going to get too hot. I just want to make sure I'm not stressing the battery out too much. And so far, it feels just fine. I think this battery is going to be great. Obviously, we're not going to have the run time that we would with bigger batteries, but yeah, looks like this is going to work out just fine. We'll give it a few more jumps and then we'll check the battery temperature just to make sure it's not getting really, really hot. See if we can get a backflip. Oh yeah, no problem. I love this XRT. This thing's pretty heavily upgraded, but even in stock form, the XRT is a lot of fun. I'm definitely curious to see what the Nitro electric hybrid does. Maybe we'll put one in something like this if it works out okay in the Funco.
I think that 911 Motorsports ramp's working pretty hard with this big, heavy XRT, but it does seem to be working pretty well. I've had good luck with it so far. All right, let's do a few high-speed rips, then we'll check and see how hot the battery's getting. I suspect it'll be just fine because this thing feels like it's got a ton of power. These Obonic batteries are usually pretty good. I mean, they're definitely not 150C like they claim to be, but overall, I've had good luck with them. All right, yeah, after a couple minutes of bashing, this battery's barely warm, so this is gonna work.
Which means we have this entire side for nitro activities, which is good because in this small space, we need to fit the engine, the exhaust, the fuel tank, the throttle servo, a bunch of plumbing, and the air filter. Before we figure any of the rest of that out, we really need to get this engine mounted up, but this thing isn't even fully assembled yet. We need to put a starter on it. Because this is technically a race engine, it doesn't have a built-in starter. It has this wheel that relies on a bump box to actually start it externally. Fortunately, LRP does sell a starter backplate for it. We aren't going to fully disassemble this motor before we run it, but I do want to mention if you're going to be doing any kind of disassembly on a nitro engine, you need to make sure your work area is very clean. A single piece of sand inside one of these engines can ruin it. And while A-Main was nice enough to send me this one, I'm not sure they're going to send me another one. Inside here, you can see the connecting rod and crankshaft. Everything looks really, really nice. You can see the connecting rod's knife edge. Those angles on the edges actually give it less air resistance inside the engine. The fuel air mixture actually comes in through the middle of the crankshaft there after it comes down through the carburetor. And then the piston itself coming down actually pushes the air fuel mixture up into the cylinder. This starter backplate has a one-way bearing built into it so that you can turn the motor externally, but when it's running, it'll freewheel. This little plate engages with a pin on the back of the crankshaft and allows us to spin the engine from the outside. Now, as a stretch goal, I do have a fully remote electric starter for this. I'm not sure if we're going to get to that in this video, but hopefully we will. For now, though, we'll keep things simple and just use this backplate along with the LRP geared roto starter. This can be mounted on here in either orientation. We're going to go ahead and mount it sticking out to the right, and that way we can use a roto start shaft with a drill to start this up, which is a lot more convenient than using a pull starter, which would have been on the wrong side anyway. Now, before we cut the mounting plate out of carbon fiber, we need to make the cradle for the motor itself. I'm going to try 3D printing this, but we're going to use this stuff called PPS CF10. PPS stands for polypropyl something or another, carbon fiber 10. This stuff is pretty crazy. It almost feels like metal. It's very brittle and it needs some pretty wild temperatures to print. Bed temperature is no problem, but my printer only goes up to 300C, so let's see if we can actually print this. Of course, first we need to go into CAD and actually create the model. This is a pretty simple design. We just need a mount with holes and the proper size ears on it. Then we're gonna go ahead and fire up my poor 3D printer and see if we can print. As you can see here, it's printing okay, though a little bit rough. And here's the final result. This thing feels really weird. It's very dense. As you can see, we didn't get a perfect print, but I think it's gonna work. Hitting this with a metal object, it doesn't sound like plastic, it sounds like ceramic. That is really, really awesome, and it should be able to handle the temperatures of the motor. And I think if we go ahead and put this on here, yeah, that's gonna fit perfectly. Now we have a nice flat surface, we can mount this on the carbon fiber. There's gonna be a lot of force on this engine and therefore on this mount. So what I wanna do is go ahead and notch this area out on the chassis. We're gonna cut these on the Carvera, but unfortunately there really is no good reference point for an origin. And in order to start cutting based on a model, you need some place to start from. Fortunately, we're covered here. We've got this little block we can put on the corner of the part, and then we can use this probe to actually tell the machine where the origin is. With that done, we can use the model I created in CAD and go ahead and create our notches. And there it is, guys. I am in love with the CNC machine for modifications. You literally could not do this by hand. I mean, you could, but it really wouldn't look this good. This is gorgeous. Let's get it on the car. I would have loved to have used this chassis plate in place so I didn't need to strip all this down, but unfortunately I couldn't fit the entire car on the bed of the CNC machine. You can open a panel in the back and it might have fit, but I really didn't want to mess with that. Of course, we'll see if I regret that once I get done swapping all this stuff out. I'll go ahead and pop these covers back on so the gears don't fall out when I flip it over. This also gives us the first opportunity to see just how well this front bearing is mounted, and it feels pretty stout. I'm hoping this is going to stay in place when we're bashing it. Of course, since this is the first time in the world this has ever happened, we have no idea until we try. Underneath the center skid is something that might give us a little bit of trouble, and that's the servo for the front brakes. This thing has mechanical front brakes that are operated when you hit reverse on the transmitter. The Traxxas receiver is smart enough to know when it's actually moving forward or when it's in reverse so that it doesn't hit the brakes when you hit reverse to try and go into reverse. Unfortunately, the Traxxas transmitter isn't going to have the functionality to do what we need to do with the Nitro engine, so we're going to be using this FlySky G11P. This thing has a lot of programming options, and I've got some ideas for how to make this work in forward and reverse with the brake, but it's definitely going to be more complicated than the Traxxas setup is. With those screws out, the back should be free. And now for the new modified midsection. And now we've got a nice flat surface here where we can use our carbon fiber to make a mount for the Nitro engine. And after designing the adapter plate in CAD, I went ahead and 3D printed it first so we can test fit it. This carbon fiber is pretty expensive and I don't want to waste it if it doesn't fit properly. As you can see, we've got slots to adjust the plate and slots to adjust the motor, and it does look like it fits perfectly on the chassis. Set the electric motor on here, and that also appears to line up just right. And the motor mount also fits. And then putting the motor onto the mount, you can see it looks like this is going to work. We're going to need some spacers to do some fine tuning here, but we can cut those out of the carbon fiber as well. But as you can see, we've now got a big beefy electric motor and a beast of a Nitro motor sitting next to each other. I cannot wait to see how this thing performs. Let's get that cut out of carbon fiber. This is going to be a pretty simple process. We're just going to mount this up in the Carvera, have it auto select the correct bit. It's going to cut the slots, drill the holes, cut the contours, leaving tabs behind so the parts don't fly around. And there we go, guys. This thing looks really awesome. I want to warn you, if you're going to be working with carbon fiber on a CNC mill like the Carvera, you need to have proper dust extraction. I'm using double HEPA filtration, but the dust created when you mill carbon fiber is no joke, and you really don't want it in your lungs. With that being said, it looks like it's going to fit perfectly. Let me get the motor and the engine installed, and let's see what it looks like. Well, as you can see, I went a little bit overboard and got everything put together. This thing looks really incredible. Let me show you what I did. We've got the motor and the Nitro engine installed. This 2-in-1 mount was a little bit of a pain because we had to do the mesh for both pinion gears at the same time, but it was doable. I went ahead and got a throttle servo hooked up. That's just connected with double-sided tape to the carbon fiber. And then we have the exhaust and the fuel tank. This exhaust is straight out the back of the engine, and it eliminates this U-shaped section of exhaust pipe. The length of the exhaust will affect the tuning on this, and I'm not really sure what the end result's going to be, but we're going to find out. And speaking of finding out, we need to get this thing broken in so we can actually go rip it. Let's get it outside and hear what it sounds like.
First off, let's give it a little preheat. Preheating your engine, especially when it's new and tight, is probably the best tip to make it start much, much easier, and it's better on the engine in general. All right, let's see if she'll start. A little bit more throttle. All right, guys, she's running great. While we get this break-in done, let's go ahead and get the front end ready to swap over.
Unfortunately, splitting this front end apart is far more complicated on the Funco than it is on the other X platform vehicles. Not only does this entire top plate have to come off, which is usually stuck by this tab underneath here, but all of this front brake mechanism also holds it together. Fortunately, since there are no drive components in the front end, this wouldn't have to be done very often, but if you do have to and you don't have power tools, I'm gonna feel pretty bad for you. And now we've got the front end on, and this thing is looking awesome. I went ahead and left the pinion off the electric motor so it doesn't put any extra drag on the engine. Let's get this outside and see what it feels like.
Well, it's moving, but it's not moving very fast. This is still under serious break-in tuning, so the engine's not going to be anywhere near full power. But yeah, it really is struggling to move this thing. We might need both the engine and the electric motor to get any sort of speed out of this. I was kind of hoping to do better with the engine, but I'm not sure we're going to. Let me finish this part of the break-in, and let's go see what this thing can really do.
Okay, well, after running through the rest of the break-in process, I can tell you that this Nitro engine really struggles to get this thing moving off the line. That should be okay, though, because the beauty of the hybrid system is how these two motors deliver their power. The electric motor has basically 100% of its power at 0 RPM and tapers off at the top, and the Nitro engine has very little power at low RPM and comes in at the top. I'm hoping we're going to have a perfect synergy between the two when we actually go out and bash it. Now, I had to set up the receiver pretty interestingly. We've got 4 connections on this receiver, one going to the ESC, one going to the steering servo, one going to the throttle servo, and one going to the brake servo. In order to make all that work properly, I've got several mixes on the G11P. When we hit forward, a throttle signal goes to the ESC, as well as activating the throttle servo on the Nitro motor. When we hit reverse, it activates the brake servo, as well as braking on the ESC. However, when we hit reverse again, it would activate reverse on the ESC, but would also activate the brakes again. Because of that, I have a button over here I can hit that'll temporarily disable the brake servo so we can actually use reverse. And I've got this slider here that'll give me a little bit of extra throttle just on the throttle servo so we can run high idle on the Nitro engine. Sound complicated enough? Let's go see if this is gonna work.
All right, guys, while this thing's warming up, if you made it this far into the video, you're already a fan of this kind of thing, so you might as well get subscribed. We've got a lot of really cool stuff coming in the future. Let's see what this thing can do. Oh, she's moving. Oh yeah, come on baby. first nitro and electric combination, and she is absolutely cooking. Oh man, this thing is absolutely rowdy, guys. This thing is crazy. Look at her shoot. It is really wet out, but I don't even know if you could hear me. This thing is so loud, but this is an incredible,
Okay guys, well that was definitely insane, but not all of it in a good way. First of all, I want to say driving this hybrid was unlike anything else I've ever driven before. It had explosive power and sounded really, really cool. Unfortunately, part of what made this awesome was also its downfall, and that's having the nitro engine and the electric motor connected together. There were two main problems with this that I didn't predict. The first one was that every time I hit the brakes, the nitro engine died. That's because the clutch shoes were still flung out against the clutch bell, and the electric motor was stopping the wheels almost immediately, also stopping the nitro engine. The second and more critical thing I failed to realize is that the electric motor can backspin the nitro engine, and I'm pretty sure we blew the nitro engine up. Right there at the end, this nitro engine spun faster than any other big block nitro engine I've ever heard before.
Is it incredible?
And after that, it wouldn't start again. Even with that though, I consider this project to be a complete success. This thing was absolutely wild to drive. It was incredible to build, and it was just a ton of fun overall. Obviously, this is just a proof of concept. The first time something's done, you're gonna find a lot of problems with it, and we found a lot of problems with this. But I do think the concept is sound, and we could refine this and make this a really formidable combination. You know what else is a formidable combination? You and me. I love hanging out with you guys in these videos. If you loved it too, make sure you get subscribed. If you want to win that thing we talked about earlier, put any comment down in the comments section, hit the like button, and check one of these videos out.